All right, IM1 classes. Today we are graphing functions. It's actually relatively simple for graphing. I'm going to give you a domain, so x values. You're going to take those x values and input them into a function to get y values, and you get an xy point that you're then going to plot on a graph. So hopefully most of this stuff is review. One thing we do need to talk about is function notation before we get into how to actually graph a function. So function notation is this part right here, the f with parentheses and the x inside. This is pronounced f of x, and it's used when notating a function. For mostly it's interchangeable with y. So if you have a function that looks like this, y is equal to 2x plus 1, you can replace that y with an f of x is equal to 2x plus 1. So we use it because it streamlines some notation. So with the warm-ups we've been doing for the last few days, I've been having you evaluate functions at certain x values. How we would notate that is just by putting an f of 3 or whatever x value you want to input into the function. You swap that in for x here, and that tells you to swap it into the function. So f of 3 means to evaluate that original function there when x is 3. So that's just what we've been doing in the warm-up. So to graph these, I'm going to give you a domain. So remember, the domain are the x values. So a domain of -2, -1, 0, 1, 2. We're going to input them into the function here. Y is equal to 5x plus 5, or if we were to put that into function notation, we would say that is f of x. F of x is equal to 5x plus 5. But we'll just use x and y for right now. So this column here is going to be our x values. This column here is going to be our y values. And then the middle column is where I'm going to put the work for the actual function of y is equal to 5x plus 5. All right. So I'm going to use this domain, the domain of -2, -1, 0, 1, 2. And then all I'm going to do is input the domain, the x value, into the function to get the output of y. I'm going to do that for each domain value. So it's going to be 5 times x plus 5, and I'm going to input -2 into the x there. And then I just evaluate that. 5 times -2 is -10, plus 5. -10 plus 5 is -5. So an input of -2 gives you an output of -5. Again, I'm just inputting the value into there. And then I'm going to do that for each domain. I'm going to streamline this a little bit. I'm going to write the function 5 times x plus 5. Organize the table a little bit. Five times x plus 5, 5 times x plus 5, 5 times x plus 5, and then I'm going to input that each x value into the open parentheses. So -1, 0, 1, 2. So 5 times -1 is -5, plus 5 is 0. So input of -1 has an output of 0. 5 times 0 is 0, plus 5 is 5. 5 times 1 is 5, plus 5 is 10. 2 times 5 is 10, plus 5 is 15. So now, since I input the x's into the function, I got my output values. That gives me xy coordinates, so -2, -5, -1, 0, 0, 5, 1, 10, and then 2, 15. I'm going to take each of these points and plot them on this graph. Not all those points are going to fit on this graph. That's okay. I'm going to fit 3 of them. I'm going to fit what I can. So -2, -5. So the x values, so it goes x, y. The x values are on the horizontal axis. The y values are on the vertical axis. So x equals -2. I'm going to go -2 on the x, then -5 on the y. So left 2, down 5. Plot my point. That's the first point there. Next one, -1, 0. You can go to -1 on the x, 0 on the y. Next one, 0, 5. 0 on the x, so I don't move left or right. 5 on the y is 5 up. Plot the points, and then I'm done. That's all that fits, so that's all I'm going to put on there. The other graphs hopefully will fit all the points. So let's do another example. So y is equal to -3x minus 1. So again, I'm going to have my x values here. The y values, gotta move my little zoom thing. The y values here, and then the work goes in the middle with the function. Y is equal to -3x minus 1. So with the function notation, you could do f of x. Again, we're just gonna stick with the x and y. So it's gonna be -2, -1, 0, 1, 2. I'm going to organize this table a little bit. And what I like to do is put in, just write out my function each time. So -3 times x, switch out the x for a set of empty parentheses. So -3 times x minus 1, -3 times x minus 1, -3 times x minus 1. And then I'm going to input the x values. I'm going to input the x values in blue here. So -3, so -2, -1, 0, 1, 2. And then I'm going to evaluate each of those. -3 times -2 is +6, minus 1 is 5. -3 times -1 is +3, minus 1 is 2. -3 times 0 is 0, minus 1 is -1. -3 times 1 is -3, minus 1 is -4. -3 times 2 is -6, minus 1 is -7. So here are my points. So -2, 5, -1, 2, 0, -1, 1, -4, 2, -7. And I plot those points on the grid here. So -2, 5. So -2 on the x, 5 on the y. So left 2, up 5. -1, 2. -1 on the x, 2 on the y. So left 1, up 2. 0, -1. So stay at 0, down 1. 1, -4. So right 1, down 4. And then 2, -7. 2, -7, it would be off the, about right there. There we go. All right, just a couple more examples. So this is what we would call a linear function because these all line up in a straight line. We're gonna have some functions that aren't linear that we're gonna deal with. We're gonna skip ahead to it's called a quadratic function, but this is what's gonna give us a parabola. We're gonna use the same domain. So -2, -1, I'll give myself a little bit more space, -2, -1, 0, 1, 2. Organize this table a little bit. So this column is the y's, and I'm going to put the work with the function in the middle. So I'm going to do the same thing where I'm going to fill it in, just replace the x's with empty parentheses. So 4x squared, 4x squared, 4x squared, 4x squared, 4 times x squared. So make sure you are doing proper order of operations on these. So after I input these x values, so -2, -1, 0, 1, 2. You need to do the exponent first. Most common mistake on these kids will just do 4 times -2 and then square that. You have to do the exponent first. So I have to do this part first. -2 squared, that's -2 times -2 is +4. So 4 times 4 is 16. So -1 squared, so you have to do this part first. -1 squared is +1. Times 4 is 4. 0 squared is 0. Times 4 is 0. 1 squared is 1. Times 4 is 4. 2 squared is 4. Times 4 is 16. Here are our points: -2, 16. -1, 4. 0, 0. And then 1, 4, 2, 16. So it looks like all these are actually going to fit on the graph that we have. So -2, 16. So I go -2 on the x up to 16 on the y. Put a point. -1, 4. So -1, I have to do a half step. Notice it's counting by 2, so I got to do a half step on the x and then up to 4 on the y. 0, 0. And then 1, 4, 2, 16. Done. All right. One more problem. All right. So only thing different is we have a negative there. So you just have to be careful with the negative. So x, y, our function is y is equal to -2 times x squared. So -2, -1, 0, 1, 2. Table, table. So here I'm going to put in, I'm just going to write it all, replace the x to get everything ready. So -2 times x squared, -2 times x squared, -2 times x squared, -2 times x squared. Fill in the values, input the x values, the domain into the function. So -2, -1, 0, 1, 2. Evaluate that. So -2 squared is 4 times -2 is -8. -1 squared is 1 times -2 is -2. 0 squared is 0 times -2 is 0. 1 squared is 1 times -2 is -2. 2 squared is 4 times -2 is -8. So now I'm going to plot these points: -2, -8. So -2 on the x, -8 on the y. Plot a point. -1, -2. So -1 on the x, -2 on the y. 0, 0. 1, -2. So 1 on the x, -2 on the y. And then 2, -8. So 2 on the x, -8 on the y. And we are done. So your assignment today is actually in Edulastic. Make sure when you click on the Edulastic link, you select sign in with Google. And then if you have any questions, make sure you email me. But that is all I have for today. So we'll see you guys next time.